For elements that are solid at standard temperature and pressure, the table gives the crystalline structure of the most thermodynamically stable form, S, in those conditions. In all other cases, the structure given is for the element at its melting point. Table. Unusual structures. Usual crystal structures. Close-packed metal structures equals. Many metals adopt close-packed structures, that is hexagonal close-packed and face-centered cubic structures. A simple model for both of these is to assume that the metal atoms are spherical and are packed together in the most efficient way. In closest packing, every atom has 12 equidistant nearest neighbors, and therefore a coordination number of 12. If the close-packed structures are considered as being built of layers of spheres, then the difference between hexagonal close packing and face-centered cubic is how each layer is positioned relative to others. Whilst there are many ways that can be envisaged for a regular build-up of layers, hexagonal close packing has alternate layers positioned directly above below each other, A, B, face-centered cubic has every third layer directly above below each other, A, B, C, A, B, C, also termed cubic close packing, FM3M, Pearson symbol CF4, struct turborite A1, double hexagonal close packing has layers directly above below each other, A, B, C, A, B, C, of period length 4, like an alternative mixture of FCC and HCP packing. I plus or minus SM packing has a period of 9 layers A, B, C, B, C, A, C. Hexagonal close packed. In the ideal HCP structure, the unit cell axial ratio is 1.633, however, there are deviations from this in some metals where the unit cell is distorted in one direction but the structure still retains the HCP space group. Remarkable, all the elements have a ratio of lattice parameters Ca 1.85. Face-centered cubic, more content relating to number of planes within structure and implications for glide-slide, for example ductility. Double hexagonal close-packed, similar as the ideal HCP structure, the perfect DHCP structure should have a lattice parameter ratio of 3.267. In real DHCP structures of the 5 lanthanides, variates between 1.596 and 1.6128. For the 4 known actinides DHCP lattices, the corresponding number variate between 1.620 and 1.625. Body-centered cubic equals, this is not a close-packed structure. In this, each metal atom is at the center of a cube with 8 nearest neighbors, however the 6 atoms at the centers of the adjacent cubes are only approximately 15% further away, so the coordination number can therefore be considered to be 14 when these are included. Note that if the body-centered cubic unit cell is compressed along one 4-fold axis, the structure becomes face-centered cubic. See also, crystal structure. References. General, Actinides and the Environment, edited by P. A. Stern, A. Gonis and A. A. Borovoy, NATO ASI Series, Proc. Of the NATO Advanced Study Institute on Actinides and the Environment, Malim, Crete, Greece, July 1996, Clever Academic Publishers, pages 59-61. ISBN 0-7923-4968-7. The Chemistry of the Actinide and Transactinide Elements, edited by L. R. Moores, Norman M. Edelstein, Jean Fugger, 3rd edition, Springer 2007, ISBN 1402035551. ISBN 978-14020355555. External links, Struct Turborite Type AA structure reports for the pure elements, crystal structures for the solid chemical elements at 1 bar.